Back. This is lecture 17, event driven programming, graphics module, event handling. This lecture covers sections 15.1, 15.2, 15.3, 15.4 from our textbook. All the relevant files have been uploaded to your Dropbox and to your Blackboard accounts. Okay. Now, an event driven programming is a paradigm where an executing program waits passively for external events to occur and then responds appropriately to those events. Okay, so what is event driven programming? Your program waits for external events to occur and then respond. All right. In other words, there is an interaction with the user. So we primarily focus on graphical user interfaces. Here is an example. If you say in your shell, name equals what input, what is your name? Well, it will wait. Try it for yourself. Name equals input. What is your name? Now it's waiting. So this is an event driven programming. All right. So I say something and it's fine. It's taken that name. All right. And after that, I can say print statement. You see, here is another example. I'm not following the textbook's CS1 graphics, but I'm using a certain other file. I've called it trial1. Okay, it's uploaded. Trial1, it has been uploaded for you. So let's run this. You will see what it does in a minute. It says click anywhere and press any key. Aha, I clicked, gave me a blue circle. Clicked, gave me a blue circle. Okay. Suppose I click anywhere, I didn't write anything. So let me say and press any key. Oh, I clicked, I press letter F, that's true. Suppose I don't click, I just press, I'm pressing now letters. Do you notice? My letters are changing. So this is another event-driven programming. Depending on the event, the program gives me a certain result. All right. We will see how to write this in a short while. Okay. Okay. We want both these examples are sequential. Sequential means you have it's only one line at a time it's going through. Okay, so for example, asking for a name and it's waiting, you give it a name, so it's only one line at a time. But typically user has more freedom to control the actions of a program. At any point, a user has the option of selecting menu items, entering keyboard unit, using a scroll bar, selecting text, and much more. For example, here is another example. So this is trial 2, which also I have uploaded. Let's run it. Look at all these various options a user has. That's a button. Of course, I'm not linked it to anything, but I can enter something. I can use numbers, I can use scale, I can use this scale. So this is all done using tkinter, okay? You can choose something. You can have this kind of choice. You can have on-off switches. You can have radio buttons, and you can quit, right? So that's what they're talking about. Usually a user has menu items. User has many more options. Event handling is an approach by which the program is able to declare various events that should be available. In other words, for a click or an enter somewhere, a choosing of a text and so on, every such event must have a consequence. Okay? So there should be explicit code that should be followed to handle each individual type of event. This piece of code is known as event handler. Okay, so let me go back to the simpler trial one. If you remember, let's run it. This was the one where you could say click or enter a letter, and you can see the changes here and so on, right? Click or whatever. So let's understand what is going on here. First, well, this is the main loop, right? These are just two functions. So you have opened a window, created a canvas. In the canvas, on the top, because y coordinate is 10, x coordinate is 200, click anywhere and press any key. That's that. Okay, with certain color and underline, all that. Okay, with this canvas, you bind a button. Uh, Button 1 is the way to recognize clicks, whereas binding a key is the way to recognize keys. You understand? So canvas.bind is a way to get information from the user. Button 1 gets you clicks. Key gives gives you one character. So when I use a click, this, by the way, one click, it means the left click. Okay. Draw circle. Okay. Draw circle. Look, I haven't invoked the function. I've just named a function. Draw circle is the function that is invoked every time I click. Give char is the function that gets invoked when I use a key. Both of them take an event. Event is just a parameter. Event.x gives you x coordinate, event.y gives you y coordinate. Likewise, repr event.char, that gives you the character that you're typing. You understand? So these are your event handlers. That is your event. That is your event handler. So for every event, you need a specific handler. All right. So that's what we are saying. We want an explicit code to handle each individual type of event. Event handlers. Often a separate event handler is declared for each kind of event. An event handler is typically implemented either as a standalone function or an instance of a specially defined class. So you can define it as a function, as I did in this example, or you can define it as a class. When Programmed as a standalone function, event handlers are known as callback functions. The appropriate callback function is registered in advance as a handler for a particular kind of event. This is sometimes described as registering to listen for an event. So, draw circle listens for an event. Give character listens for an event. Okay. Now, handlers are therefore sometimes called listeners. Each time such an event subsequently occurs, this function will be called. With object-oriented programming, event handling is typically implemented through an event handling class. An instance of such a class supports one or more member functions that will be called. Okay, this you will have to see in a few minutes. Okay, it takes a little more work. Event loop. The design of an event-driven software is quite different from a traditional flow-driven. So that's an important thing to note. Okay, event-driven software doesn't go one line after another line after another line, because here I'm doing whatever the user does, and it doesn't really go through this particular line. User has his or her own mind to press a click or press in a key, you see. So design of event-driven software is quite different from our traditional flow-driven programming, although there is still a concept of the main flow of control. When the software first executes, initialization is performed. These things you might be able to, this is getting verbose, and I'm afraid you might have a hard time understanding. It's best to try some examples first. Okay, let me just show you this one picture before I continue. Main program, it is an, in some sense, an infinite loop. If you have a handler for one event, another handler for another event, and so on, that's how you would work, right? For example, here is binding, so that is handling, this function is handling this event, this function is handling this event, and so on. There is a main loop going on, right? For example, this program is still running, it has not finished because I'm still going on, right? So main loop goes on. When one event is triggered, handler 1 takes over. When event 2 is triggered, handler 2. So they can happen anytime. You don't have a control of which one is to be implemented when. So it depends on the user. When they click, you have to address that. When they enter letters, you have to address that. Okay, so this is an important, so the event loop keeps on happening. Okay, threading is an important, well, it is a very small piece of information, but I have a few examples to show you. I want to show you threading in the next video. Until then,